Hi guys, today we're doing some trigonometric identity problems. These problems involve the angle sum or angle difference trigonometric identity, and I've listed for both of our benefits the two trigonometric identities down the bottom here. So we've been given these two trigonometric ratios, sine of 105 degrees and cosine of 105 degrees, and we've been asked to find the exact value of each. So when you've got a question that says exact value in it, you're pretty much rest assured it's going to have some sort of surd or square root in it somewhere. So the way we utilize the angle sum identities in these problems is through the fact that we can say that cosine of 105 degrees is going to be equal to the cosine of 60 degrees plus 45 degrees. And so what we can do then is, because 60 plus 45 is 105, these two ratios are exactly the same. So what we do then is the identity becomes quite easy from there if you know your exact values, because we can just substitute. If we're going to use these identities down here, we're going to be substituting like 60 in for A and 45 in for B. So what we can do is we can say that cosine of 60 plus 45 is going to be equal to the cosine of 60 times the cosine of 45 subtract the opposite. We usually use with this identity, we use the opposite sign that's from what's in the brackets, subtract the sine of 60 times the sine of 45. So basically you have to know these off the top of your head if you're going to be doing an exam without any calculators or without any notes. So we have to know that the cosine of 60 degrees is a half. And we're going to times that by the cosine of 45, which is 1 over the square root of 2. We're then going to minus the sine of 60, which is the square root of 3, over 2 times the sine of 45, which is also 1 over square root 2. So what we can do then is we can multiply together on either side of that subtraction sign, and that's going to give us 1 over 2 times the square root of 2, subtract square root of 3 over 2 times square root of 2. Now, because they're on the same base now, we can actually subtract them. So this is going to equal, we'll just put it over one base, 2 square root 2, and it's going to be 1 minus the square root of 3. Now, most people will ask for their fractions at the end to be left with a rational base, so we have to rationalize the denominator. So with that, we multiply it by square root 2 over square root 2. So we're going to times it by, in effect, timesing it by 1. So we'll times it by square root 2 over square root 2. And then what we have to do is on the base is going to be 2 times the square root of 2 times the square root of 2, which makes 4. Because the square root of 2 times the square root of 2 is 2, multiplied by 2 is 4. Then the square root of 2 is times by 1, so that's just going to be the square root of 2. Subtract the square root of 3 times the square root of 2, which is the square root of 6. And that is our solution for the first problem. Now, let me just separate these before we move on to the second one. So what we have here, we've got the sine of 105 degrees. Now again, what we're going to be doing is we're going to split this, like we did for the previous one, into the sine of 60 degrees plus 45 degrees. Now, again, we're going to recognize that this in our identity is going to be A, and this in our identity is going to be B. Now, once we have those, it's simply a plug and play. We're just going to plug in those numbers into this identity, which you will be expected in some higher level geometry or calculus classes to know. You're just simply going to plug in these numbers for where the A's and the B's sit inside the identity. So what we can see now is that this is going to be equal to the sine of A, which we know is 60, times the cosine of B, which we know is 45, plus the cosine of A, which is 60, times the sine of 45. Now, once we've got that, again, it's we go straight to our exact values for each of these trigonometric ratios. We know the sine of 60 is the square root of 3 over 2. Times by the cosine of 45, which is 1 divided by the square root of 2. We're going to add to that the cosine of 60, which is a half, times sine of 45, which is 1 divided by the square root of 2. Now, exactly the same as we saw in the last problem, we can then multiply before the addition sign and after the addition sign. And we're going to be left with the square root of 3 over 2 square root 2, add 1 times 1 is 1 over 2 times the square root of 2. Now what that equals, we can combine the bases because they're the same, and we can just add the numerator, and we're left with the square root of 3 plus 1 divided by 2 square root 2, and as we did in the previous problem, we're going to multiply the numerator and the denominator by root 2 over root 2, so we can rationalize our denominator. And finally, we're going to be left with, oh, it's blue, that doesn't matter, 2 times root 2 times root 2 is 4. So we've got 4 in the base. 3 times root 2 is the square root of 6. Add the square root of 2. So basically, once we know what our exact values are, and once we know that we can break the angle that we have in our trigonometric ratio up into its components of which we know the exact values for, we can then plug those exact values into a trigonometric identity, whether it be the sine, the cosine, there is one for tangent as well. And if we plug them in, substitute them in and get our exact values for each component, multiply them all together, and then we're going to finish off with a nice exact value fraction. So I hope that little video helped, and I'll see you again next time.